Hello, my name is Rebecca Parks, and we're going to be going over exactly what perimeter and area is, and we're also going to go over two different ways to show it and figure out what it is. Now, perimeter can be defined as a continuous line forming the boundary of a closed geometric figure. As you can see with our square here, the green rubber band is our perimeter. It is closed, there's no gaps, and is forming a boundary line of our entire square. Now the area is the number of squares that can be contained within it. So each of our squares, we've got 1 square, 2 square, 3 square, 4 square. And that's going to make up our area. Now for this lesson we're going to be using mainly geometric figures, but we're also going to go over how to approach non-geometric figures and figures that don't exactly fit up with our squares. Now first we're going to go over our square and how exactly to get our area and perimeter with that. The first way we can do it is using our GeoBoard. Now as we said earlier, it's the continuous line with no spaces. So we've got the whole line right here. And there's no spaces. So each peg to peg is one part of area. So we're just going to go around 1, 2, 3, 4, 5, 6, 7, 8. So now, as we can tell from each peg, there's 8 total in the perimeter. Now what about area? Our area, as we said, is the squares that can be contained within the figure itself. Now, we have to go from peg to peg on the inside now. We made 1 square, 2 square, 3 square, and 4 square. So our total area of this square would be 4. But what about using the formula? Now, formula for perimeter is P equals A plus A plus A plus A. Now A stands for each of the sides of our square. So when we counted them, 1, 2, 3, and so on, all this formula is saying is that we're going to add all of these together, just like we just did, and that's going to equal our perimeter. Now area, our formula is B times H. Now the B stands for base, and that's the base of our square, and H stands for height. You could also do B squared, which would be B to the second, or B times B. Now what is B? Well, remember how we had counted our squares? We're doing the same thing, but using our edges. So our B is 1, 2, that's a total of 2, and our H is 1, 2. So now let's plug this in. We've got 2 and 2, so 2 times 2 equals 4. And how many squares did we count originally? Counted 1, 2, 3, 4. So that's the easy way to find perimeter and area with our square. But what if we had a little bit of a harder figure? A rhombus, as perfectly geometrical as it is, we're going to have to use some mental math. So first, let's line up our rubber band. Okay. And as you can tell, our perimeter is a little bit different than our square. So we've got peg to peg, remember? So we've got 1, 2, and then what happens here? Well, using our GeoBoard, we can see that there's a square on the inside for our area, but there's a triangle right here. But what is half a square? Now if we look, 2 triangles of the GeoBoard makes a square. As shown here, we stretch this, there's our square. So if we go back to our original shape, and we see that we have one square and then one triangle, we can say that our area is 1 point. Moving on to our hexagon. First, we're going to start with our perimeter. We just line up our rubber band with the shape. Now, it's not perfect, but this is just a demonstration. And first, our perimeter. Remember, we're going to be counting our pegs. So we've got 1, 2, 3, 4, 5, 6. So our total perimeter is going to be 6. Using our A plus A plus A plus A being each side, adding it all together, it's 6. Now for the area, we're going to have to use the same mental math. Now first, let's connect our dots. So we've got 2 squares, 1, 2, and remember, as we said earlier, our 2 triangles make 1 square. If we stretch the rubber band, we've got 1 square. So let's see, how many triangles do we have? 1, 2, 1, 2. So since 2 triangles make 1 square, we've got 2 triangles, that means 1 square. 2 triangles, that means another square. And then we have 2 full squares. That's going to be, our area is a total of 4. Now when it comes to triangles, we're going to have to constantly be using the same mental math. Now let's measure our perimeter again. Got 1, 2, 3, 4, 5, 6. A plus A plus A plus A. 1, 2, 3, 4, 5, 6. It's a total of 6. And I'm now counting our area. We can't, now the triangle, if we connect it, we can't make our squares. So what would we do? This is when we can use our equilateral triangles. See how they're all the same? They're all the same length. We can use our perimeter to find our area. So let's count the base. Remember, the bottom of our shape, the base of our triangles. So we've got 1 base, 2 base, 3 base, 4 base. So that's going to be this line's perimeter. From this peg to this peg is 4. 1 base, 2 base, 3 base, 4 base. So that's going to be 4. 1, 2, 3, 4. Now earlier we used a formula, base times height. So we've got our height, and we've got 1 height, which is our 4. And then the bottom 4. So 4 times 4 is going to equal 16. Now what happens if we count these individual triangles? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. And we just found our triangle's area using our GeoBoard with just triangles. And that is how you would properly find area and perimeter using your base times height, your perimeter A plus A plus A, and your GeoBoard. Thank you.